the lengths of two tangents from an external point to a circle are equal. Now, going forward with the statement goes as the lengths of two tangents from an external point to a circle are equal. Let's understand what we need to create in the figure so that we can prove this theorem. We need to have a circle. So let's take a circle with center O and we write in the given a circle with center O. We require an external point for the circle and we know there are infinite number of points in the exterior, out of which we take one point as P. So P is a point in the exterior of the circle. And from this point P, we need to have two tangents to the circle. So let's draw the two tangents. So PA and PB are the tangents from P to the circle. Remember, A and B are the points of contact. We need to show that the lengths of these two tangent segments are equal. So we need to prove PA equal to PB. Let's see what should we do. We remember for a circle, if we have a tangent and if we see the center and the point of contact, we can easily draw the radius. We draw segment OA and OB as the construction. So we draw OA and OB. Okay, talking about PA and PB, we need to get these two sides equal. The best way of proving two sides equal is by proving the two triangles containing these sides to be equal. That means in order to prove PA and PB equal, we need to identify two triangles which can be proved congruent. Let's look for them. Do we see any triangles in the figure? The answer is no. But we can always create them by drawing OP. If we draw OP as the third construction, we now see two triangles. We see triangle PAO and triangle PBO. In these two triangles, that is triangle PAO and triangle PBO, let's observe these two angles, angle OAP and angle OBP. We know that the radius is perpendicular to the tangent. That means angle OAP and angle OBP will be equals to 90 degree. Radius is perpendicular to the tangent. Let's now check whether the hypotenuse of these two right angle triangles are also equal. The answer is yes, because OP and OP are equal. They are a common side. Okay, so hypotenuse OP is equals to hypotenuse OB, common side. Further, do we have one more pair of congruent sides? Yes, we have OA and OB to be equal. You know why? Because the radii of the same circle. That means these conditions are sufficient to say the two triangles, triangle PAO and triangle PBO, are congruent by the RHS rule. Now what happens if two triangles are congruent? We know if two triangles are congruent, the corresponding parts are also congruent. From that we can say PA equals to PB. The reason is CPCT. Hence, the lengths of the two tangent segments or the lengths of the two tangents drawn from an external point to a circle are equal. Let's identify this. Let's understand this further. Here we have a circle which is an incircle for a triangle. How many points do we see in the exterior? There are 3 points, namely A, B and C. Let's look at point A first. Which are the tangent segments, which are the tangents from A to the circle? AP and AR. And we know they are equal. Let's take point B. Name the tangents from B, BP and BQ, and again they are equal. What about C? CQ and CR, and they are equal. But what should be the reason? The lengths of two tangents from an external point to a circle are equal. Let's take a little further challenging figure. How many points in the exterior? 4. P, Q, R, S. Let's take point P first. Tangents from P to the circle, PA and PD, and we know they are equal. What about Q? We have two segments, two tangents from PQ to the circle, QA and QB, and again they are equal. What about point R? RB and RC, again they are equal. And what about S? Further, SD and SC are equal. But what should be the reason? The lengths of two tangents from an external point to a circle are equal, and that's what we need to learn here.